So far we have seen the algorithmic understanding of bubble sorting algorithm, right? Now is the time for us to implement it using JavaScript. Okay, for that I am inside the project that I have created in the project setup video. Now let me go ahead and create a folder called sorting here, because I want to put all these sorting related implementations inside a single folder. In this sorting folder I'm going to create a new file called bubblesort.js. Okay, now here we will be writing the implementation that we have discussed previously. For that, let me write a class called bubblesort. Okay, in this let's implement a function bubblesort. Okay, it will be taking a array by the name arr inside the variable arr. Now, as per our pseudocode that we have written, we have to repeat the comparison logic that we have to do for n number of times, right? For that, I'm writing a for loop. Let's say var I equal to 0. Let's use let, not var. I is less than arr dot length, and I will want to go to the next index in each and every iteration. Now, here is the actual for loop which we use for comparing two adjacent values. So I also mentioned in the pseudocode that I will be starting with the index 1, right? So that I can compare the previous element with minus 1th index. So for that I'm defining a variable, I'm defining a loop. Let's say let j equal to, j will always start with 1, because if we start from 0, 0 minus 1 will be minus 1. Array will not have an index minus 1. As a result, you will face array index out of bounds exception. So make sure that you are running from the index 1, and j is less than array dot length and j plus plus each and every time. Now we will have to compare the values at j minus 1th index and jth index, and if the value at j minus 1th index is greater than the value at jth index, we will have to swap it. Now how will we swap it? First we have to compare, right? If AR of j minus 1 is greater than ARR of j, then we will have to swap. So how will we swap? Let me copy the value of some array of j into some temp value. Okay, now let's assign array of j equal to array of j minus 1. So we move the value from j minus 1th index to jth index. Now we will have to, whatever the temp value we have here, we will move it to ARR of j minus 1 equal to temp value. Do you see? It is exactly like the pseudocode that we have already written. Now let's call this function and execute. For that, I'm going to create an object to the class that I have created. Let's say b equal to new bubble sort, and from this bubble sort I want to call b dot bubble sort, and let's say I want to sort the array containing values 0, 3, 2, 11, minus 10. Okay, in the end, as part of this bubble sort function, I did not return anything, but let's return ARR. Okay, I mentioned that it is an in-place sorting algorithm, right? Bubble sorting is because we are simply comparing the values at certain indexes and we simply swapping. So whatever the array that we get, in that array itself, all the values will be sorted in the ascending order or the descending order based on the type of implementation you are doing. So if we run this logic, it is returning ARR, right? Let's try to copy it into some variable. Let's say const sorted array equal to bubble sort. Now let's try to log it. Console.log of sorted array. Okay, so we have initialized the class bubble sort. From that we are calling the bubble sorting function. We pass some values, and in the end we captured the return sorted array, and we are simply printing it. Okay, now let's try running it. How will we run? Node, this file is inside the folder sorting, right? So what we have to do, sorting, basically we will have to give the complete path of the file. For that node sorting, inside the sorting, the file name is bubble sort. If I run it, do you see -10, 0, 2, 3, 11. Even if you pass one value or 100 values, program that we have written will make sure that it is sorting the values in the ascending order. Okay, just to show you how can you actually perform the descending order sorting, I'll simply copy this function and let me name this function as descending order. Okay, do you remember while explaining the algorithm I mentioned whatever the comparison logic that we are doing, if we do the opposite one, we will be able to perform the descending order sorting as well. For that, I'll simply modify this comparison operation to less than, because since we are trying to store the values in the descending order, right? If the value on the j-1 index is less than the value at jth index, then we will have to swap, right? That's why I'm doing a less than operation here. Okay, in the end, let's try calling that function also. Control C, bubble sorting descending order. Okay, let's execute it. Do you see? We see 11, 3, 2, 0, -10, which is the descending order. Okay, this is how actually the bubble sort is implemented using JavaScript.